Hi all, we are meeting today again for 11th standard trigonometric formula. First of all, thank you for showing an interest in yesterday's video, watching it properly. Our two students, Pratik Shinde from Solapur and Anaga Naik from Pune, have solved a 12th standard example based on what I did yesterday. They attempted the 12th standard integration problem from the textbook. Yesterday I had solved. Similar to that, there is one sum in the textbook and shared those sums on WhatsApp. Thank you Pratik and Anaga, you are showing interest. Both the sums were correct. You have used the formula correctly. Good work. I am happy. It keeps me encouraging to do more videos. Keep it up and enjoy today's video also. So आज हम लोग देखने वाले हैं हाफ एंड फुल एंगल फॉर्मूले used in 12th standard derivatives. Okay. So these are 11th standard formulae used in 12th. तो पहले देखेंगे क्या क्या फॉर्मूले. 1 plus cos theta, if you get 1 plus cos, now how to remember? If you get 1 plus cos, right hand side 2 cos square. If you get 1 minus cos, राइट हैंड साइड को आता है 2 sin squared. तो ऐसा ध्यान में रखना. इफ यू गेट 1 plus cos, you get 2 cos squared. ब्रैकेट के अंदर क्या लिखना है? हाफ द एंगल थीटा बाय 2. इफ यू गेट 1 minus cos, राइट हैंड साइड को क्या लिखना है? 2 sin squared, हाफ द एंगल थीटा बाय 2. ओके, सो remember these two. Then instead of 1 plus cos, if you get 1 plus sin, you have to remember a plus b bracket squared. लेकिन इसका हाफ एंगल लेना है. cos theta by 2 plus sin theta by 2 bracket squared. If you get 1 minus sin theta, cos theta by 2 minus sin theta by 2 bracket squared. They can be proved by starting with the RHS and using the formula a plus b bracket squared, but no need to prove. Okay? You have to remember them. If you get only sin theta, most sums, as we are going to see one 12th standard problem, sin theta अगर आया तो राइट हैंड साइड को 2 sin cos और इधर क्या लिखना है? हाफ द एंगल 2 sin theta by 2 cos theta by 2. Okay, that is why I have written half angle, and here the full angle, complete angle is getting converted into half angle. So if you get sin theta, 2 sin theta by 2 cos theta by 2. If you get cos theta, cos squared theta by 2 minus sin squared theta by 2. ध्यान में रखना cos theta को 4 फॉर्मूले. cos theta, first formula is cos squared theta by 2 minus sin squared theta by 2. Second formula is 2 cos squared theta by 2 minus 1. Third formula is 1 minus 2 sin squared theta by 2. And fourth formula 1 minus tan squared theta by 2 upon 1 plus tan squared theta by 2. Now I'll just give you some time so that you can freeze this moment and pause करके सब फॉर्मूले लिख लेना when you watch it next time, or you can do it right now also. Write down all these formulae. Okay. So it has been clear that left hand side there is theta, right hand side it is theta by 2. You have to take half of that angle. जो कोई एंगल आएगा उसका हाफ लेना है. Taking one example will make it more clear. The most important and useful formula are the first two. बहुत जगह पे यूज करने वाले हैं. और एक बार पहले दो देखेंगे. If you get 1 plus cos, right hand side 2 cos squared half the angle. If you get 1 minus cos, right hand side 2 sin squared half the angle. आया ध्यान में? So should we begin? Okay. Even if you get 2 theta over here, इधर अगर 2 theta आया तो 2 theta का हाफ क्या रहेगा? थीटा रहेगा. So for example, if you get sin 2 theta, right hand side you are going to get 2 sin theta cos theta, 2 theta का half. But if you take theta here, then it is theta by 2, and I explained yesterday you cannot cancel एंगल का थीटा और ये थीटा कैंसिल नहीं कर सकते. Okay, so these are different set of formulae than what we saw yesterday. Let us take one example from 11th and one example from 12th. Hope you are ready. 11th standard exercise 3.3, prove that 17th sum 2 cosec 2x plus cosec x is equal to sec x into cot x by 2. ये प्रूव करना है. सो आई एम स्टार्टिंग विद द लेफ्ट हैंड साइड. देखो 2 cosec 2x plus cosec x, लेफ्ट हैंड साइड चालू किया. Now there is no formula for cosec 2x, but you know that cosec is the reciprocal of sine, sine is the reciprocal of cosec. So when there is no direct formula, it is better to convert into sine and cos. लेकिन ध्यान में रखना रेसिप्रोकल कौन सा रेसिप्रोकल है. रेसिप्रोकल ऑफ साइन इज कोसेक, रेसिप्रोकल ऑफ कॉस इज सेक, रेसिप्रोकल ऑफ टैन इज कॉट, एंड द अदर वे अराउंड आल्सो. सो बिकॉज रेसिप्रोकल ऑफ कोसेक इज साइन, 2 ऊपर है, when I take cosec in the denominator it gets converted into sine, because sine is the reciprocal of cosec, cosec is the reciprocal of sine. तो ये 2 upon sin 2x लिखा है. होप इट इज क्लियर. 2 को कुछ किया नहीं है. If it was sec over here, it would have got converted into cos, because sec is the reciprocal of cos, or cos is the reciprocal of sec. Anyway, now 2 upon sin 2x. यहाँ पे अभी बोला है मैं cosec is the reciprocal of sin, so 1 upon sin x. Right? So sin में convert कर दिया. So after converting into sin, which formula can you see? देखो sin 2x. Sin 2x is 2 sin x cos x. ये कहाँ से आ गया? This formula. Formula 5 में क्या लिखा है? sin theta is equal to 2 sin theta by 2 cos theta by 2. Therefore sin 2x will be equal to 2 sin 2x upon 2, यानी इसका हाफ लेने का है. So sin 2x is 2 sin x cos x, right? Sin theta is equal to 2 sin theta by 2 cos theta by 2. So 2x का half is x. So I take an x here and x here. Just writing in bracket formula 5. So for sin 2x, 2 sin x cos x. ये 2 ऊपर है. sin x के लिए 2 sin x cos x. 1 upon sin x, I have kept it as it is. 2 को कैंसिल करो. What remains is 1 upon sin x cos x plus 1 upon sin x. Now if you see carefully, how to simplify this? Either you can take the LCM directly here, or as I told you some days ago, in most of the simplification it is better to take something common. तो अभी common क्या दिख रहा है? देखो 1 upon sin x is common. So 1 upon sin x common ले लो. यहाँ से अंदर क्या है? 1 upon cos x plus 1. 1 upon sin x has gone outside, बाहर चला गया वो. So what remains? 1 upon cos x plus 1. So when you take 1 upon sin x outside, 1 remains over here. 0 नहीं है, 1 remains. Okay. Have you followed this step? 1 upon sin x common. बाद में क्या किया है? I have simplified this bracket. Cos x is the common LCM. Right? And as we have seen many times, 1 के नीचे कुछ नहीं है. So it is 1 plus 1 into cos x. 1 plus 1 नहीं करना है. Cos x is the common LCM. 1 plus 1 into cos x, that is cos x. So 1 plus cos x upon cos x आ गया. This is what I get. अभी ये आने के बाद क्या करना है? ये आने के बाद observe the right hand side. Now comes your logical thinking. How are you going to think about completing the sum? राइट हैंड साइड यू हैव cot x by 2. यहाँ पे हाफ एंगल आ गया है. So because half angle is present in the RHS, I have to use this formula, half angle formula. Where do I use? Sin x, sin theta. What is sin theta? 2 sin theta by 2 cos theta by 2. So what will be sin x? 2 sin x by 2 cos x by 2. Simple. ये हो गया. cos x को कुछ मत करो. 1 plus cos x. 1 plus cos x, first formula. If you get 1 plus cos, क्या बोला है मैंने? 2 cos squared half the angle. So if you get 1 plus cos x, 2 cos squared half the angle. So 2 cos squared x by 2. इसका half. 1 plus cos theta, 2 cos squared theta by 2. Right? So for this I am writing 2 sin x by 2 cos x by 2, 2 cos squared x by 2. Over here and over here. दोनों जगह पे हाफ एंगल फॉर्मूले यूज किए. Now see, we'll complete the sum now. 2 gets cancelled, 2 gets cancelled. You have cos squared x by 2 and here cos x by 2. तो एक cos x by 2 कैंसिल हो जाएगा. स्क्वायर में से एक cos x by 2 will remain. Now let us see what remains. Cos x by 2 upon इसके नीचे sin x by 2. I'm writing below this and into cos x by 2 लिखा है. What remains? 1 upon cos x. हो गया सम सॉल्व. cos x by 2 upon sin x by 2, cos upon sin is cot x by 2. 1 upon cos is so cot x by 2 into sec x, which is what is required in the RHS. Sec x into cot x by 2. That is our RHS. Right? So the important thing was, after converting into sin and cos, we use the formula for sin 2x. 2 sin x cos x. Cancel 2. 1 upon sin x common निकालने के बाद we use the formula for 1 plus cos x and sin x again. It was necessary to use the formula for sin x because after writing 2 sin x by 2 cos x by 2, 1 cos x by 2 gets cancelled. cos x को कुछ किया नहीं because 1 upon cos x goes in the numerator as sec x. Sec is the reciprocal of cos. ये तो पक्का मालूम ही होना चाहिए इसका reciprocal क्या है. So that is your RHS. Followed? Clearly? Okay. Now इससे सिंपल एक प्रॉब्लम है 12th standard derivatives. You already know about derivatives, so we'll solve this together. लिख लो. Ask for CET. Find dy by dx if y is equal to tan inverse root of all that. अभी आप सोचेंगे अरे रूट आ गया क्या करेंगे अभी. No need to worry. सिंपल है. लिख लो पहले. Once you get used to this formula, you will start thinking अरे CET में भी ऐसे सिंपल सवाल पूछते हैं. Okay, I will solve. देखो अभी 1 minus cos. Simple. Just go to 1 minus cos. What is 1 minus cos? 2 sin squared half the angle. 1 minus cos 2 sin squared theta by 2. So 1 minus cos will be 2 sin squared. पहले 2 sin squared लिखना है. उसके बाद हाफ द एंगल मीन्स 6x upon 2. सिंपल. यहाँ पे 1 प्लस कॉस रहता तो 2 कॉस स्क्वायर लिखते हैं। साइन थीटा, साइन 6x को हाफ एंगल में करना है तो कैसे करोगे दोस्तों? अभी देखो, थिंक ओवर माय फ्रेंड्स, हाउ विल यू डू दिस? यहाँ पे किया है, यहाँ पे किया है, साइन थीटा इज 2 साइन थीटा बाय 2 कॉस थीटा बाय 2। सो सिर्फ साइन आया, सो आई एम गोइंग टू राइट 2 साइन कॉस। Sin theta is 2 sin theta by 2 cos theta by 2. So sin 6x will be 2 sin 6x by 2 cos 6x upon 2. Simple. Now inside, yesterday I told you, you are not allowed to cancel this 2. ये 2 cancel नहीं हो सकते, लेकिन एंगल के अंदर cancel हो सकता है। 2 3 6, 3x, 2 3 6। यहाँ पे आई वोंट कैंसिल, नहीं तो कॉम्प्लिकेटेड हो जाएगा। डू इट ओरली, बाहर का 2 कैंसिल हो जाएगा। तो 2 3 6 यानी यू गेट साइन स्क्वायर्ड 3x, 2 3 6 साइन 3x। सेम एंगल के अंदर यू आर अलाउड टू डिवाइड, 2 3 6 cos 3x, sin 3x गेट्स कैंसिल, साइन स्क्वायर में से एक साइन रहे ऊपर रह जाएगा, सिर्फ स्क्वायर कैंसिल कर रहा हूं। लिख लो व्हाट रिमेन्स, राइट डाउन। Since you have done some derivatives, you will be able to get this also. What remains? Sin 3x upon cos 3x. Sin upon cos is tan. Right? Now, so it has been simplified to this step. Okay? इतना simplify हो गया। अभी ये simplify होने के बाद you have to take the derivative. So you know how to take the derivative? dy by dx, d by dx of tan inverse root of tan 3x. Okay, now I'll just explain the procedure. This derivative is not there for you in the 11th standard. इसको chain rule बोलते हैं. The important part was how to simplify up to this step using trigonometric formula. अभी ये आने के बाद d by dx and a derivative of tan inverse x. Now in the 12th you are going to learn that derivative of tan inverse is 1 upon 1 plus x square. Okay, derivative of tan inverse x. Derivative of sin x is cos x. You know all those things. So in the 12th standard you are going to learn derivative of tan inverse x. तो derivative of tan inverse x का formula use करने के बाद you have to take derivative of root of tan 3x also. That is called as chain rule or derivatives of composite functions. That I will not explain over here. After you reach 12th standard, then we'll again repeat this problem. Okay. So d by dx means now it is quite simple to use the derivative trick and solve the problem by using derivative of tan inverse and derivative of tan 3x. So important part was how to simplify this. How to simplify this to get this. तो ये आने के बाद you can take the derivatives. Clear? Okay. Now there is one more thing that I want to tell you. Suppose, ये problem में suppose in certain cases you get like this. Supposing this root sign was not there. If that root sign was not there, you will get only this. बराबर है? अगर ये root sign नहीं है, so you get derivative of tan inverse tan. Now there is again one formula in 12th. Tan inverse tan gets cancelled. This derivative of 3x remains. Derivative of 3x कैसा find out करना है? Now this is the 11th standard problem. 3 constant, keep it outside d by dx of x. We have solved this. 3 is a constant, keep it aside, derivative of x. Derivative of x is 1. 3 is the answer. So sometimes when the root sign is not there, then directly we get tan inverse tan. But when the root sign is there, we cannot use the formula for tan inverse tan. Then you will have to use the derivative rule of composite functions. So both the cases are possible. कौन सा भी problem पूछ सकते हैं, either with the root sign or without the root sign. So we have seen the basics of all these formulae. These are also important. First two are very important along with this. Clear? So that will be all for today. We will take some more examples in a few days. Monday को ले लेंगे. Maybe trigonometry or some other concept. So practice this. लिख के लो. We'll meet next time. Bye. See you.